All right, two more powers or exponent rules. We're going to do the power rule and the zero power rule. The power rule applies when you have an exponent on the outside of a set of parentheses, and we treat it like kind of like the distributive property, actually. So you're going to kind of take it and distribute the exponent to the exponent of each of the letters, variables in the problem. The key thing to remember is that this 5, it actually has an exponent. It has an an implied 1. All right? As you distribute, what we do when we're distributing is multiply. So what you're multiplying are the exponents. We're still going to have a 5, an A, and a B, but we're going to multiply the exponent. 2 times 1 is 2. 2 times 4 is 8. 2 times 3 is 6. And while this is a fine answer, you really do need to actually do this part. 5 squared means 5 times 5. So 5 times 5 is 25. And then the A and the B were already finished. Okay? So if you look at it, we did 5 squared. 5 times 5 is 25. And then we multiplied the exponents. 4 times 2 is 8. 3 times 2 is 6. So that's a brief reminder for the power rule. For zero power, does anything to the 0 power equals 1. So this part, this A to the 0, is the same as 1. This 0 does not belong to the 5 because the 5 has an implied exponent of 1. Anything to the 0 power is 1, so it's like saying 5 times 1. And 5 times 1 is 5. So that would be the answer for that first one. For this one, though, it's a little bit different because this 0 exponent is outside of these parentheses, which means that it affects the entire set of parentheses. Since anything to the 0 power equals 1, then this whole thing to the 0 power has to equal 1. And that's the end. Okay? In class, we explained why. Right now, we're just reviewing, so if you'd like to know more about why, just ask. All right, so here's 3 examples that we'll do really quick just to make sure that you got it. Again, this big number in the front is the coefficient, and the exponents right there. And then we have the extra exponent on the outside that we're going to use. This is the power rule, which means that we're going to multiply the exponents. Kind of like the distributive property, you're going to multiply them. This 2 has an implied 1 as its exponent. But this negative 2 is actually one number. So when we take this out of these parentheses, we're going to keep the negative 2 like that. 1 times 3 is 3. We're going to have an x and a y. 3 times 3 is 9. 3 times 3 is 9. And we're just going to finish this up by doing negative 2 to the 3rd power. What that means is negative 2 cubed times negative 2 times negative 2 in Desmos parentheses, negative 2 to the 3rd power equals negative 8. And the x to the 9 and y to the 9 stays. So that's the answer. All right. This problem has that 0 exponent, the 0 power in it. This term actually equals 1. So we could rewrite the problem 4m cubed times negative 3n squared. Okay? This kind of goes away because it equals 1, and anything times 1 is itself. At this point, we need to follow the rules for multiplying because this is a multiplication problem. When you're multiplying, you multiply the coefficients, and you add exponents. 4 times negative 3 is negative 12. We're going to have an m and an n. We have 3 m's here, none here, so in total we have 3. Here we have n squared. There's no n's here, so it stays n squared. And that's the answer. So that 0 power just cancels out. It makes it equal 1. All right, last one. This one has multiple steps to it, so we're going to kind of take it bit by bit. The order of operations says groups, which we have a group up here, so we're going to do that first. Exponents. So we need to take care of this exponent and this exponent first. So we will use the power rule. The power rule says that you multiply the exponents. Remember, this is like an implied 1 in front, negative 1. So 1 times 2 is 2. X, y. When you're doing power to power, you multiply. 2 times 4 is 8. 2 times 3 is 6. So that takes care of this part. The second part, we have this negative 1 that's right here. 4 times 1 is 4. X, y. 4 times 0 is 0. 4 times 3 is 12. And we haven't touched the denominator yet, so we're just going to leave it like that. All right. We have completed using the power to power rule. Or power rule, however you want to call it. And now we're going to move on to multiplying because we still need to finish this group at the top. But before we do that, we need to simplify any exponents that we have. Right here we have 2 squared. 2 squared is 4. X to the 8th, y to the 6th. Negative 1 times 4, or to the 4th power, is negative 1 to the 4th power equals positive 1. You could not write that if you wanted, or you can write it. It's totally up to you. Divided by negative 2x to the 8th, because we haven't done that yet. Now we need to multiply. When you multiply coefficients, and then you're going to add the exponents. 4 times 1 is 4. We have x's and y's. 8 plus 0 is 8. 6 plus 12 is 18. And we haven't even touched the denominator yet. Okay. I hope that you guys can see what we've done here so far. We're going to finish up the problem. All right, now we're going to work with the denominator. The rule for division is that you now divide the coefficients. So 4 divided by negative 2 is negative 2. We're going to have some x's and some y's. 8 minus 8. Remember, now when we're dividing, we subtract the exponents. Is x to the 0 power. And the y has nothing to subtract it with. There's no y's down here, so we're just going to keep that 18. We have nothing in the denominator, so now we're going to just make this more beautiful by getting rid of that 0 power. Sorry, I ran out of some space. Negative 2 is great. X to the 0 power is the same as 1. Y to the 18th power. And let's just finish that up. Negative 2y to the 18th power. That's the answer. So this entire thing right here simplified to that tiny little answer, and that's why we do this, to make it easier to work with. This problem is complicated, but if you take it step by step, you can absolutely do that. All right, see you later. Bye.